On this example, we're given an angle, pi over 6, which actually works out to be a very nice angle, one that we see a whole lot within this class. And our goal on this is to find sine, cosine, tangent, cosecant, secant, and cotangent to go along with this. Evaluate each one of these at that given angle. So I'm going to be referring to a chart that goes along with some of these nice angles that's listed down here below. I typically just learn this for cosine, sine, and tangent. There is another chart that goes along with secant, cosecant, and cotangent, but for the time being, I'm going to ignore that. We can derive each one of those pretty easily as long as we understand our reciprocal identities. So when we're given either pi over 6, pi over 4, or pi over 3, these are very nice angles. They go along with 30 degrees, 45 degrees, and 60 degrees. As we get going on this, let's go ahead and use this chart to evaluate sine of pi over 6, cosine of pi over 6, and tangent of pi over 6. So for this, what we're going to be doing is we're looking at this column to go along with it. And we can say, well, cosine is going to be square root of 3 over 2. So kind of fill in up above here with each one of these values. Sine is going to be 1/2. And then we can also go ahead and say that tangent is square root of 3 over 3. So after we have those three based on the chart, what I'm going to do is suggest that we understand our reciprocal identities to go along with cosecant, secant, and cotangent. So what I mean by that is that cosecant is the reciprocal of sine. And each one of these pairs for sine and cosecant, each one of the pairs has one of them starting with an S and one of them starting with a C. And it takes a little bit of practice, but we'll get that down. So what we have with this reciprocal relationship is cosecant of pi over 6 is actually 1 over sine of pi over 6. Or what you can do is, since we have a value here, the 1/2, we can take this value and invert it, do its reciprocal, meaning numerator and denominator switch places. So we can say this is equivalent to 2 over 1 based on sine being 1 over 2. With just a little bit of reducing down here, we can say that's equal to 2. Okay, we can do something very similar with secant of pi over 6 is the reciprocal of cosine of pi over 6. So we can say 2 over the square root of 3. Now with that solution, we still have a radical in the denominator. It may look a little bit nicer if we rewrite this and rationalize the denominator by multiplying numerator and denominator by the square root of 3. The goal here is to get rid of the square root from the denominator. So in multiplying the numerators, we can say 2 multiplied by the square root of 3. And for our denominators, we can say the square root of 3 times the square root of 3 is the square root of 9, or that's equivalent to 3 with a little bit of reducing down. Finally, cotangent and tangent kind of go hand in hand, but they're reciprocals of one another. So what I'm going to do is invert the square root of 3 over 3. We can say 3 over the square root of 3. And again, we may want to rationalize the denominator by multiplying numerator and denominator both by the square root of 3. What this is going to do is give us 3 multiplied by the square root of 3 all over the square root of 9, which works out to be 3, with just a little bit of reducing down. The 3's that are not underneath the radical can cancel out, make a 1, and we'll be left with the square root of 3. All right, hope this helps out. I would suggest as you're working on homework, have this chart handy so that you can get used to it, familiarize yourself with each one of these values, and get comfortable with this. I would not advocate getting a second chart here. It's twice as much work. Just get down your reciprocal relationships that there's always an S and a C in each pair. So secant goes with cosine, sine goes with cosecant, and cotangent and tangent go hand in hand. They're just reciprocals. All right, hope this helps out. Good luck.